everyone, welcome to the Junior Astrophysicist. My name is Akash and now we're going to be looking at the first video of my channel. In this video we'll be learning about planets and the laws of planetary motion along with some basic equations. Right, let's begin. So basically a planet is a body in space which orbits a star. In our solar system it's the sun. Okay, then after that, they must have the gravity to force them into a spherical shape and enough gravity to deflect other foreign bodies in outer space. Yes, so when you look at our solar system, just a second, rub everything off. Okay, so this is our sun. Okay, so we are orbiting this sun, which is a star. Now we have orbits. 1, 2, 3, 4, 5, 6, 7, 8. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Sorry, I forgot to add the 8th one. You can see the orbits now. And in these orbits, these are the planets. See, these circles down here, everything, all these planets are here are the planets. And this is the star. So we call the first 4 planets, Mercury, Venus, Earth, Mars, as normal planets. And there's an asteroid belt here. Asteroids are bodies in space which are similar to our rocks on Earth. Okay, so I'll just keep this belt down here. These are called the gas giants. If you want to know why, these planets are made of gas and they are not made of solid particles. They're totally made up of gas. So we call these the gas planets or the gas giants. It's Jupiter, Saturn, Uranus, and Neptune. Okay, now forget everything. This is just the basics of our solar system. There are tons of solar systems in the universe which we have not known up to today. Okay, fine. I'm again going to take off everything. Now, we'll be doing the laws of planetary motion, which was framed and coined by a man named Johannes Kepler. This man was an astronomer. So astronomers are people who study stars, who study space, who study the galaxy, who study the universe. Okay? Yes. So Johannes Kepler framed 3 laws of planetary motion. Planetary motion. Yes. According to the first law of planets and planetary motion, all the planets must have a star in our solar system, the sun, as the center of foci. So if this planet is in movement in its orbit, it must have a center of a star. Okay? Imagine this is Mercury and this is Sun. Okay? Yes. Mercury is orbiting the sun. So according to his idea, there should be a star in the middle. Okay. Now, this is the first law. Now, the second law states that if the orbit is closer to the sun, now we'll take an example of both Mercury and Neptune. Okay? Yes. This is the sun again. When it's closer to the sun, when the mean distance of a planet is lesser, then the speed of its movement in its orbit is going to be higher. Okay? Yes. It's a bit of a tough thing to understand all of this. But some people might ask the question, why is this happening? Why only when it's close to the sun, the orbital period is less? The answer to that comes only after you study the theory of relativity, which I'm actually working on right now, and I'm nearly somewhat halfway through. I'm actually working on it. This comes from the gravity part of it. Oh, we'll just focus on that later, but for now, we'll just go with the second law. So when the mean distance of the planet is less from the sun, then its orbital period would be less too, because the planet moves at a higher speed. But if the distance is high, then it moves at a lower speed, so the orbital period is high. Fine. Now we'll just go for the third law, which states now that according to the third law, the orbital period of a planet in years. Okay, let's take is divided by the number of astronomical unit measurement of that planet and the sun. Okay, count in astronomical units. You can unit in astronomical units, but it's the mean distance from the sun and the planet. You will get an answer of x. Just keep it that way for now. And this x is common for all the planets in our solar system. Okay, just a second. I'll just collect the data down here. So, 1 second. Yes. So for Mercury, your period in years is 0.241, and your average distance is 0.39 astronomical units. So the value which we have taken as x in this equation is 0.98. I would first tell you that not all the values are exactly similar, but they are approximately equal. Okay, yes, fine. So Venus is 0.615, 0.72 astronomical units, and 1.01. Okay, yes. And in Earth, 1 year, 1 astronomical unit, 1 is your answer. And then yes, it's the same. It's nearly approximately the same for everything in our solar systems. All the planets in our solar system can be found with this. Okay? This is their arbitrary motion. This equation is for their arbitrary motion. In this video, I have shown you the basics of planets, and I will also frame some equations which you can use too. Like you can frame your own equations, but these will be the basic understanding for the 3 laws. Yes. Now for the second law. With the first law, it doesn't really have an equation, so we'll just begin with the second law, in which S is equal to the sun. So in this equation, I would say that when the distance of the planet is lesser, okay, it is equal. So this is not a proper mathematical equation. I'm telling it to you. Don't think of it as a proper mathematical equation. This is just for understanding, okay? You can frame original mathematical equations using this. So D is less when the distance is less. Distance from sun is less, then your speed is higher, okay? Equals less orbital period slash higher speed and movement. Yes. Now for the third law, as I had already written down there, the orbital period square, I'm sorry, I didn't really mention it, but the orbital period square divided by the mean distance from the sun cube. This is in years and this is in astronomical units. You will get your answer, okay? So these are the 3 laws of planetary motion, which is coined by Johannes Kepler, and we have seen what are planets. So in our next video, we'll be working on something much more related to astrophysics and astronomy too, okay? So don't forget to like this video, share this video, and don't forget to subscribe to my channel. Click the notification bell for more videos and notifications of my videos. You'll be back with a lot of new planetary videos and also astrophysics. See you guys. See you soon. Bye.